Determine the number of two-person groups that could be generated from the 5 available students. All right, so I'm going to take this one from scratch. I'm going to make a tree diagram. We have 5 people available, and I want two-person groups. All right, so I have person 1, 2, 3, 4, and 5. I know I didn't write the numbers 1, 2, 3, 4, or 5, but there are 5 people. Albert. Doesn't really matter. We're just trying to think. Oh, I can do that. Yeah, Alfred, Bruce, Catwoman, Dent, and Edward Nigma. Yeah, yeah, I got it. I can do it. All right. So if I'm placing any of these 5 people as the first person in the group, maybe they're the team leader or something like that, then order would matter. If you're the first one selected, then you're the leader. After that, you're not. But this doesn't really say that. It just says we're going to be groups, so we're going to assume equal partnerships. All right. So after the first person is placed into the group, the other possibilities would be maybe B is with A, then C is with A, D, or E. Oops. All right. Now I'm gonna go through this as if it were a permutation and say any possible pairing of 2 values. All right. So and then we'll make adjustments after the fact, even though some of these won't make sense initially. I might say if I have B, then I could have A, B, then C. The one thing that we know is that you can't have a group of 2 consisting of just the same person. So I can't have a group of B and B, right? Unless I can somehow reproduce Bruce into 2 individual people, so clone them or something. Then that's not going to happen. So I'm basically in my second level here, really. I'm just noting everything except for what I had in the first level. All right. So I have a tree diagram, a complete tree diagram with, it looks like 20 values. That's what we would get as a permutation. Right. But if we're grouping people, again, we would want to have it so that only unique people make up the group. All right. So I'm going to start making a sample space out of this. All right. So my SS, AB, AC, AD, AE. That addresses the first group, or the first tree, branch? I don't even know how to say it. All right. But then, now I'm going to, so let me just circle that in black. Now I'm going to take care of this one. I'm going to write BA, BC, BD, PE. All right. So if we're reasoning this out, and we're going to say, I'm the teacher, I'm going to put together groups of 2 out of the class, and say, okay, Alfred and Bruce, you're going to be in one group. All right, you're going to be group 1. Bruce and Alfred, you're going to be group 2. Naturally, those 2 guys are going to look at me and say, well, which one is it? Are we group 1 or group 2? We're confused. You put us in 2 different groups. All right, so obviously I didn't need to account for them twice. So A, B, and BA mean the same thing in this context. Now, if I told you that the first person selected gets the grand prize of $10,000 and the second person selected gets a piggy bank with a quarter in it, then it really does matter who gets selected first. All right, so context is really important. All right, so then we have CA, CB, CD, and CE. So I look at this and I say, okay, wait a minute. I add an AC, CA, that's the same as that. I had a BC, I don't want to cross that one out. CB is the same as that, but everything else looks like it's okay. All right, so then we get to color-wise purple. I think we're up to. We can do DA, DB, DC, and DE. All right, looks like we already have an AD, so DA doesn't need to be there. Looks like I have a BD, so DB doesn't need to be there. And generally, you want to avoid DBs. CD and DC. Half an hour later, that joke will kick in. As soon as you figure out what DB could possibly stand for. Anyway. EA. EB. UC. ED. EA I already have. EB I already have. EC I already have. And ED I already have. And it's a joke that I can't pay off for you because it involves potty language. So. Anyway, out of the 20 possibilities, looks like we're only keeping 10 of them. That's a lot of extra work that I didn't need to do. Although I didn't know I didn't need to do it until I did it. So at least the first time it was worth doing to explore it. But let's try to investigate how on earth this played out the way it did. All right, so I had 20 overall. And it looks like I'm only keeping half of it. So we're dividing that 20, we're taking that 20 and dividing it by 2. All right, so that's giving us 10 possibilities. All right, so first I would want to think about where the 20 came from. All right, so the 20 is coming from the number of arrangements which we would express as, well, we started off with 5 people, and we wanted 2-person groups, so 5P2. You do it by hand or on the calculator, but that's going to give you the 20, all right? So then I would want to be thinking about where the 2 came from. That's actually also a number of arrangements. All right, but specifically of the 2 persons that make up the group. All right, so that's the kind of thing where it's like, I give you that relationship and you say, okay, sure, sounds good. I don't know that I was coming up with that myself. I'll tell you, I don't know that I was coming up with that myself either. It took me a while because the rule for combinations is pretty out there, and I kind of needed to invent this for myself in order to understand it. It really, it's a formula that when you look at it, it's like, okay, it's just I could plug stuff in here and get numbers. And that's what I did as a student because we didn't have an NPR, NCR function in our calculator. So I had to just follow the formulas. But then I got older, I was able to play around with it like quicker. And that's what the graphing calculator brings to the table. It allows you to explore math quicker. so that you don't have to dedicate years of your life in order to understand a concept. You can spend instead days. All right. So, and actually, that gives me a great deal of admiration for the people who really truly did discover this, because when they had to make a graph, they had to make a graph like on paper, and they didn't have pre-printed graph grids. Like, you couldn't go to the store and buy graph paper. You just had to make it happen. So when you see some of those old texts, you look at some of the graphs that they produced, they're incredible for what they were working with. And add to that the fact that they couldn't make any mistakes because they're dealing with those feather pens. I don't even know what they're called, the inkwells. Yeah, where's the whiteout? No whiteout. Crumble it up, throw it away, say some curse in another language, and then start over again. Yeah, oh, we got a lot of I just hit undo. If I really don't like the mistakes I make, I just don't post the video I made. I'll post one from a previous semester. There's a lot of stuff that we can do to avoid that, but they couldn't. So a lot of admiration there. But anyway, we got our answer by taking the 5p2 and dividing it by 2 factorial. All right, that was the 10. Oh, well, that's the 10 as a result. I don't want to jump to that. The 20 over the 2, which gave the 10. All right. Now, what this is the number of combinations of 5 things taken 2 at a time. Number of combinations of 5 things taken 2 at a time. All right. So the issue that comes up when dealing with permutations versus combinations is really the underlying concept, because the setup, the work looks very similar. In fact, the phrasing of questions are very similar from a permutation question to a combination question. So what distinguishes one from the other? The classic way of explaining it is that the order matters in a permutation. The order does not matter in a combination. But and that's kind of an oversimplification, but it's a good place to start, I guess. I like to think in terms of real examples where, like what I was talking about before, the first person selected gets a grand prize. The second person gets a gift card. Lotteries. I mean, if your name was being drawn, one of those 50-50 lotteries, you go to a carnival and you buy it, you get the little raffle ticket. So the first one selected, actually it's usually the other way around, right? It's like the last one that they select from it is the one that wins the grand prize. But bottom line is, depending on where you fall in the selection process, you get something different. Yeah, and that's I was at a fundraiser last week, and it was the same idea. You entered into this raffle, and there were a bunch of different prizes that you could get, and they would select. They were like, okay, now we're going to select for this one, which were Giants tickets. This one was for the fully stocked liquor cabinet. This one was for whatever, and so somebody won the Giants tickets. They were not happy. They won. They were one of the winners. They wanted the second prize. They were having a party or something, or maybe they're just raging alcoholics. I don't know. Either way, but so one way or the other, they decided they wanted one thing as opposed to the other, and where they were selected did matter. I don't think like drafts, like in sports, I don't think they fall in the same category because it's not random.
What is random?
Random would be chosen without any regard for.
Or like computers does it.
Either way, right? Like even like drawing marbles from a bag or something like that. But it's without any preconceived notion of why you're picking what you're picking. So, yeah, I mean, it may seem like the Giants are picking at random, the Mets are picking at random, the Knicks are picking at random, all the teams that I like. Um, I wore a Giants hat today to protect my head from the rain.
Donald, right?
What's that?
You guys should take Donald.
No, I'm happy with Barkley.
Long term?
I'm never happy with anybody long term because you know what could happen is like we draft Darnold. We've had Eli for the last 15 years, never got injured once. So the next quarterback we get, he's gonna blow out his knee in week 3. So it doesn't like we've used up our good luck on health on quarterbacks. That's probably some variation of law of large numbers, but
You guys went pretty all in on Eli. I'm just saying, law average. He's got a 50.
yeah. I kind of called it last year when they picked Barkley. I'm like, I know how the story ends. We bomb out, and we get the first overall pick or second overall pick in the following draft and draft a quarterback then anyway. So I don't know. They're just not as good quarterbacks now. But I just liked Barkley. He just seems like a good person. Great player. He just needed an offensive line. Oh. God, I hate that. But anyway, I went into my closet looking for hats. I was like, all right, Giants suck. I don't want to wear that hat. Ranger, okay, they suck. Met, nope. Knicks, no. I have nothing. I have no teams. I'm no, I'm loyal to them, but they suck. It's one of those things like you put the hat on and you're immediately depressed. That's what it is. It's like you're putting depression onto your head, literally. Yeah. I don't know. Is there a local soccer team that's good? I'm not a soccer guy, but the Red Bulls, are they any good? NYFC is good. They're watchable, competitive.
I felt the same way last week. I was gonna put my Jets hat on. I swear.
Is it soccer season?
I mean, they still play for us mostly. I don't really follow it that much. Mexican, my brother.
I think they're a little better than the Knicks and Mets and.
I mean, at least because at this point in my life, I mean, when I was younger, I would have the TV on. I'd be watching like popcorn, like watching the game, analyzing everything. Now it's like I got work to do, grading papers. I just have it on in the background. It almost doesn't even matter what's on in the background as long as there's noise emanating from the box. It's not even a box anymore. But yeah, so I'm happy to throw on a soccer game, just anything. I just need something.
Definitely this year and last year football season.
Oh my God, it's terrible. It's just like I
just want to follow the formula.
How do we do it? Yes, that's what we're getting to. Yeah, this was the discovery question to give us an underlying sense, and then the next one is going to be like, all right, now this is how you really do it. But I threw in this NCR business here because this is really the way to get from beginning to end without doing all the middle stuff. All right. Now, just understand, when you're in a jam, all that middle stuff can get you an answer. It could even get you the right answer. But let's say it doesn't get you the right answer. It may get you enough of the credit that you're satisfied. You know, you showed enough work. You demonstrated that you had the right idea. You just didn't get the right answer. So out of 5 points on a test, you only lose 1 point for getting the wrong answer. I mean, but doing that work, you have something to show for the effort. You know, because that's one thing. Like in the early going of my career with probability, my stock phrase was, well, it's probability. It's a number. If you don't get the number, you don't get the answer. Like it's all or nothing. Like I don't even see how you would show work. And then I learned probability, and I was like, oh wow, actually, there's a lot of ways in which you can demonstrate work. So if you have you can't remember if it's NCR, NPR, you know, just take a shot at it. Maybe make a tree diagram. First of all, making the tree diagram may guide your thinking in one direction as opposed to another. You're like, oh wait a minute, it's definitely NCR because I don't need these guys. You know, so it can help you along that route. But it could also give you some supporting details, and that's enough information for me to give you credit. right? As long as you're demonstrating knowledge and skill, that's what I'm looking for, right? Now, how do we get from this baby to this one without all of this stuff? Well, we go to our calculators. Here they will. Okay. I tend to hand that off. They listen to a lot of things I say. We have a good relationship. So this one would be 5C2. Because again, we have 5 things. So this is our number of things. And they're taken 2 at a time. I can't fit 2 at a time in there without making it look terrible. So 2 at a time. So number of things taken at a time. All right. So I start off with the 5. I go to math, probability, option 3, it's the NCR one, and then type in the 2. And then hit enter, of course. And you get your 10.
The NPR one we only use, as you said, only if they don't ask for arrangements, right?
NPR is when they do ask for arrangements. This is when you don't care how they are arranged. You just want the individuals. All right. Yeah, so yeah. They're different mnemonics. They're not always the best because they generally require you to memorize something, but most people say if you see the word arrange or arrangement, it means permutation. But that's just you memorizing a fact. In fact, I would go the other way, and not even the other way. I would just adjust that to say, forget about the word permutation. If I see arrange or arrangement, I'm going NPR. I would even simplify that further on my note card and say arrangement means math probability option 2. Like just cut to the chase, like because eventually you're going to see that it means NPR when you hit math probability option 2 and NPR comes up on your screen. Right? So, if you gotta memorize something, memorize that. And it's not even memorizing, it's just remember to put it down on the card. I think that the word combination is a terrible name for this topic because of what I had mentioned last class, the combination locks. You can't open a combination lock unless you know the right permutation, which is not a combination. Because the order matters. If I tell you the code is 127 and you put in 721, you're not getting in. Right? So people have said that that's helped them in the past. They just say they know that it's not what they think. So they think combination lock, and it's not what I think. That helped, but I think that it's that kind of stuff that makes probability difficult, and in a lot of cases, math in general. Charlie.